So yeah, we're at IBM.
Yep.
Yeah. And what are you showing?
We're showing this a cell processor demo where we're rendering a picture of Mount St. Helens that was recorded by satellite about a year ago. So Mount St. Helens is sampled at about 2-meter resolution, and some LiDAR height data was taken, and this software is creating a 3D model on the fly by mixing the height data with the satellite color data. So rather than rendering with triangles, what we're doing is we're rendering by projecting rays from the point of view and reflecting them off of objects that are in the scene until they reach a light source. And in that way we're computing what the color of each of the pixels is.
So it's actually a cell processor.
This is a cell processor.
And that's...
this is an example of a cell processor.
All right.
The cell processor consists of a PowerPC and 8 synergistic processing elements, which is our acceleration architecture. Each synergistic processing element...
you can show the picture of it there?
Yeah, it's underneath that window. So there's a PowerPC here with 8 synergistic processing elements. Each synergistic processing element has a 32 gigaflops at well, it's actually a little bit less than that, but at 4 gigahertz it'd be 32 gigaflops. We're running the machine right now at 3.2 gigahertz.
Yeah.
And we're rendering at a frame rate of about between 20 and 30 frames a second. Which
high definition 3D.
This is 720p.
720p 3D graphics.
High definition.
Yeah. High definition.
As I say, we're doing a relative of ray tracing called ray casting.
Yeah. All right, so this process...
So you could pilot if you wanted to.
So it's supposed to pilot it like this?
Yeah. I got to switch. He's got to switch you over.
.720p. All right, it's going.
Yeah.
All right.
Give you a little gas. I'll give you a little bit of oomph here.
Oh, I'm not gonna crash.
You might.
Nice. So this is amazing because a G5 would be 40 times slower.
So if you were to render with the G5, it'd be about half a frame a second.
Yeah.
And so you're running right now about 20. So it's about a factor of 40.
Can I shoot?
No, there's no shooting.
Okay.
That's in the next one. This is a new peaceful world, don't you know?
All right.
Cold War is over.
All right. so this small cell processor is working.
Yep.
And how long time has it been working?
Well, we've had this demo running in various locations around the world for about a year.
Yeah. So, but now it's starting to be produced, or?
We've entered production. IBM will have a blade product available a little bit later this year. The blade product will feature 2 VEs on at first a double wide blade, but later a single wide blade.
Okay, so double wide blade or single wide blade, and the point is that it can encode video or do different kinds of things 40 times faster than
There's a range of applications where our software developers have shown us very significant performance advantage over conventional systems. A lot of them have been in the media space, but we're broadening our range of applicability to scientific physics modeling and business application software.
Yeah, let's just make a break. So hi, you working on the cell processor?
Yes, I'm Jim Kale. I'm the chief architect and chief scientist of the Cell Project.
All right. So can you say something about how does it compare to the best that AMD has and Intel has?
Well, the unique features we have is we started the multi-core. IBM was the first one with multi-core designs. We had 2 core designs with Power 4, and with Cell we're introducing 9 cores on a chip. So we have significantly more cores than our competition. They're very power efficient and are going to be able to give you capabilities in multimedia processing that are unparalleled in the industry.
9 cores. Do you think that's going to be expensive to have such a computer with 9 cores?
Well, the way we design it is very power efficient and very area efficient, and we're designing this to go into game consoles type systems. So we're appropriately positioned for those high volume kind of markets.
But Like the PS3 will have 9 cores?
9 cores in it.
9 cores. All right, but IBM is not involved in the PS3.
Yeah, we jointly manufacture the chips with Sony that will be in the PlayStation 3.
Ah, you do? Okay.
Yes.
All right. So this is like gonna be available in computers, like for professionals and people who need processing power.
Well, we're looking at other places we can take it beyond the gaming space, but I mean, it has, it's got a full power processor on it, 64-bit power processor. It's able to run the Linux operating system and many other features. So we made sure this was fully capable of running, standard operating systems, and we've open sourced a lot of the software stack that goes with it, so people can develop applications and other stuff.
For example, is it possible to encode high-definition video in real time?
Yeah, it's possible to do such things in real time. Yes.
So real-time, high-definition entertainment and video.
Yeah, that was one of our strives. Is really to put down real-time applications and interaction with humans, and it was a very key feature of the chip, how we were going to interact with people in real time. So decoding, encoding in real time was a very important aspect of some of the performance attributes we wanted.
Do you think it can go in a consumer electronic, like a camera?
Well, we're going to start here. Over time, technology is definitely shrinking and lowering power over time. So it's a matter of time when such things are going to be capable. It won't be right away, but
So for start, there will be like this will be inside a computer. You cannot just buy it alone and put it on yourself, or.
We don't have any right now. I mean, we're exploring lots of different avenues of different systems that can be put into. There's different announcements from different companies that are working with us that things like that might be possible.
All right, but you can just buy a motherboard and the cell processor, and you just plug it in.
Well, it's not going to be compatible with an x86 motherboard, but there'll be other ways that these things could be interconnected.
You need a special motherboard.
Yeah, this is specially designed for some of these other applications, so it won't go into a standard motherboard.